Very often, people who shoot using minutes of angle ask, why would somebody choose mils? I've seen videos that try to answer this question, but I don't think they answer that question in a way that really gets to the heart of the issue, at least not the ones I've seen. So this video is going to explore that question with the following steps. First, we're going to talk about why do people choose MOA. If you're asking this question, you've probably already chosen minutes of angle, so I'm kind of just going to meet you where you are and build off of that. Then we're going to move on to a simple analogy and sort of one sentence that sums up the explanation. And then we're going to talk about applying a mathematical formula with inputs and outputs. And we'll move on to degrees and radians and which one is the appropriate tool for different tasks. And each of those steps is going to get a little bit more complicated as we go through them. And as you get further into the video, you might encounter a point where the question of why would somebody choose mils has been answered for you. But if you watch to the end, this explanation will point to a fundamental reason why mils are more suited to our task in long-range shooting than minutes of angle. So why do people choose minutes of angle? From what I can tell, people choose minutes of angle because they see a chart like this showing that 1 MOA is 1 inch at 100 yards, and meaning that an adjustment of 1 MOA on a target at a distance of 100 yards is going to result in a 1 inch change in your point of impact. Now, it technically isn't 1 inch, but 1 is close enough and gets good results. We'll revisit that not technically 1 inch in depth later on. And as the chart shows, this pattern is easy to follow as the distance increases to 200 yards and 300 yards and beyond. Now, you probably see mils presented alongside minutes of angle on the same chart, showing that 1 mil is 3.6 inches at 100 yards, 7.2 inches at 200 yards, 10.8 inches at 300 yards, and so on. While there is a pattern to the mils, it's definitely not as easy to remember and easy to work with when it's presented this way. So people who like yards and inches gravitate towards the minutes of angle. And this chart also prompts the question, why choose mils? Because when you look at it, it seems like minutes of angle would be the obvious choice. So to use an analogy, often in shooting, the analogy of tools in the toolbox is used to describe learning different techniques, and you can choose whichever tool suits you best for whatever task it is that you're trying to accomplish. For example, if I told you that the task is to sink a nail into a board, the appropriate tool for that task would be a hammer. However, you could absolutely use a wrench to sink a nail into a board. That's not what a wrench is designed for, but it's still very effective for that task. In this analogy, the minutes of angle are the wrench, and the mils are actually the hammer, meaning that when you really dig into what mils are, you will see that they are better designed for the task that we are trying to accomplish. For our goal in long-range shooting, minutes of angle accomplish that goal by coincidence, while mils accomplish that goal by design. It may not appear to be the case based on the chart we just saw, but it is just a coincidence that minutes of angle have this nice pattern, and I'll dive into the specifics of that coincidence later on in the video. This chart actually represents the application of mathematical formulas. Don't worry about what the formulas are for now. Instead, let's just look at how formulas work or how they're applied. For any formula, you'll have numbers that you enter into the formula. We call them inputs. And those inputs go through the formula and come out the other side as results or outputs. In this chart, the ranges to the target are the inputs, the 1 MOA or 1 mil is our formula, and these numbers underneath that are the outputs. For example, if we take 100 yards and put it into the 1 MOA formula, we get 1 inch as our output. If we take that same 100 yards and put it into the 1 mil formula, we get 3.6 inches as our output. You may notice that we're using yards for our inputs, but we're getting inches in our outputs. This is actually not what you expect when you apply a formula. Usually you would expect that if you use yards for your input, you should get your output in yards too. So whatever units you put into the formula should be the units that you're getting out of the formula, unless that formula is specifically for converting from one unit to the other. So the formula that this chart represents is not just 1 MOA or 1 mil. It's also doing the extra step of converting yards to inches. So watch what happens if we remove that extra step of converting yards to inches and instead just look at the mils side of the chart when we use yards for our input and get yards for our output. Now we see that 1 mil is 0.1 yards at 100 yards. It's 0.2 yards at 200 yards, 0.3 yards at 300 yards, and so on. Now the mil side of the chart has an easy to follow pattern. You can take that 0.1 yards and convert it to inches to get 3.6 inches. If you want your formula to give you an output in inches, you could also change your input to be in inches. The 100 yards becomes 3,600 inches. And again, the mil side of the chart has an easy to recognize pattern. The 1 mil at 3,600 inches is 3.6 inches. 1 mil at 7,200 inches, 7.2 inches. 1 mil at 10,800 inches, 10.8 inches. So when using mils, there is an easy to follow pattern and formula as long as you understand that you will get your answer in the same units that you measured your distance to the target. If you measure in yards, you'll get a fast and easy answer in yards. If you measure in inches, you get a fast and accurate answer in inches. You can use mils with any unit to get that fast and easy answer. It could be yards, inches, feet, miles, meters, kilometers, centimeters, any units. With minutes of angle, you will only get that fast and easy answer if you measure your target in yards and you want your answer in inches. Even if you measure your distance in feet, you're probably going to want to convert it to yards before trying to understand your adjustments in minutes of angle. People often make the misconception that mils are a metric unit. That's incorrect. Mils are perfectly usable with yards. The difficulty is just converting yards to inches. It's complicated to convert yards to inches in any context, even if you're not trying to work with mils or doing precision rifle shooting. Multiplying by 36 is just not something that the average person can do intuitively. But that's not really a problem with mils specifically, that's a problem with yards and inches. So when using mils, you just apply this simple formula to the range to the target. You take that range, represented by the letter R, and you divide it by 1,000. That's it. Just remember that it will give you an answer with the same units that you use to measure the range. Once you have that answer, if you want to convert it to a smaller unit, you can. If you measure the range in yards, the mil formula will give you an answer in yards that you can convert to inches if you feel you need to. When using mils, we're actually applying the mathematical formula for mils. When using minutes of angle with yards and inches, people don't actually use the mathematical formula for minutes of angle. Instead, they just remember that 1 MOA is 1 inch per every 100 yards. So side by side, based on the way people end up actually using these units, it looks like this. When presented with the two actual mathematical formulas side by side, they look like this. In these formulas, again, the letter R is the range to the target. Looking at these two, I have a hard time imagining why anybody would think it would be faster and easier to use the minutes of angle formula. Let's take a further step back and take a broad view of the concept behind these formulas. Remember, minutes of angle is a subdivision of degrees, and mils, short for milliradians, are a subdivision of radians. For any task involving measuring angles, you could choose to use degrees or you could choose to use radians. Both will allow you to accomplish your goal, but depending on what the task at hand is, you might be better off choosing one over the other. You might find the answer of which unit is more suited to your task by exploring the definition of degrees and radians. A degree is a unit of angular measure where 360 degrees represents one full rotation. Often angles are viewed in relation to a circle, so in this definition of degrees, we can consider the one full rotation to represent one complete circle. A radian is a unit of angular measure that, when placed at the center of a circle, creates an arc on the circle that has a length equal to the radius. Now, this may be hard to understand just from the definition, so let's use an example to illustrate a radian. Imagine a pizza that's 12 inches across. That 12 inches across represents the diameter of the pizza. The radius is half of the diameter, so the radius of this pizza is 6 inches. If you cut a slice of this pizza using 1 radian as the angle at the tip of the slice, it would result in a slice that has a crust that measures 6 inches, which is equal to the radius of the pizza. If you cut a slice using 1.5 radians as the angle at the tip, it would result in a slice that has a 9-inch crust, 1.5 times the radius. Now let's say our task is to cut this pizza into 8 equal slices. If we want to know what size angle we should use to cut each slice, we could find that angle using degrees or using radians. Let's look at how to do that using each, degrees and radians. For degrees, we know that 360 degrees represents the whole pizza. So if we want to slice the pizza into 8 equal slices, we just divide that 360 by 8, and we get 45 degrees. That's pretty straightforward. To find this angle using radians, it's a little more complicated. The radian relates specifically to the radius of the pizza. So if we want to divide the whole pizza evenly, we have to first find out how many radians are in the whole pizza. And the formula for the number of radians in a circle is 2 times pi. We have to use pi here to accurately describe the number of radians in a circle. It's just unavoidable. Now that we know how many radians are in the whole pizza, we can divide that by 8 for 8 equal slices. That gives us 2 pi over 8, which we can reduce down to pi over 4 radians. So to divide that pizza into 8 equal slices, the angle we need to use can be described as either 45 degrees or pi over 4 radians. For this specific task, I think that degrees are the better choice. Using degrees, the numbers were all pretty simple and divided evenly, but when using radians, I had to first take the extra step to build out the entire circle with radians, which means involving pi, and then my math became a little bit more complicated, and I still needed to have pi in my answer in order to describe that angle accurately. After doing this task, it's clear that degrees allow you to break up a circle into even parts. And radians can do that, but it's a little bit more complex to do it with radians. Now let's say we have a different task. Let's say we wanted to take that same pizza that's 12 inches across, but instead of cutting it into 8 equal slices, now our goal is to cut just one slice, and we want that slice to have a 3-inch crust. What size angle would we need to use to get that one slice with a 3-inch crust? Remember that the radius of this pizza is 6 inches. Using radians, we know that an angle of 1 radian will cut a slice with a 6-inch crust. If we want a 3-inch crust, we can just use 1/2 a radian, or 0.5 radians, to get that 3-inch crust. To complete this task using degrees, it gets a little bit more complicated. Remember from the definition of degrees, it mentions 1 full circle. So in order to use degrees, we need to first understand the measurement of the outside of the circle, not just the radius. Right now, we know that the circle has a radius of 6 inches. We can multiply that 6-inch radius by 2, then multiply by pi to get the circumference of the circle. So this pizza has a whole crust that measures 12 times pi inches. If our goal is to get a slice with a 3-inch crust, we can set up a ratio where the 3-inch crust that we want is placed over the total 12 times pi crust of the entire pizza, and compare that to our unknown angle over the total 360 degrees. And then after some algebra and reducing fractions, our results show that the angle in degrees to cut a slice with a 3-inch crust is 90 over pi degrees. So in summary, to get that 3-inch crust slice, the angle that we need to use can be described as either 90 over pi degrees or 0.5 radians. So for this task, I think radians end up being easier to use. The math with the radians was pretty simple and straightforward, but calculating this angle with degrees, we first had to build out the entire circle, which means pi is going to be involved, and then it becomes sort of a mess with math and pi, but we did get there. Remember, after completing our previous task, we said that degrees allow you to break up a circle into even parts. We're going to amend that statement to say that degrees allow you to break up a circle into even parts relative to the whole circle, or to the circumference of the circle. On the other hand, Radians allow you to break up a circle into even parts relative to the radius. This is key to why milliradians are the right tool for our task in long-range shooting. So a variation on that last task would be, on that same pizza, how many inches would the crust be on a slice cut with a 0.75 radian angle? So we'll just multiply that 6-inch radius by the 0.75 to get 4.5 inches. If I said, how many inches would the crust be on a slice with a 45-degree angle? First, you would calculate the circumference, 6 times 2 times pi, then multiply by 45 over 360 to get a crust length of 1.5 times pi inches. For the purpose of calculating the crust size using a specific angle slice, if you know the radius, then it's easier to calculate using radians. So how do these examples relate to precision rifle shooting? If we go back to our chart, these ranges to the target represent the radius of our pizza. And these point of impact changes represent the size of the crust for one slice using the above angle. If we want to calculate the crust size relative to the radius, then radians are going to be a more appropriate unit for measuring that angle. The radians, which become mils, will give a straightforward answer, but the degrees, which become minutes of angle, will result in more complex math involving pi. Remember, this 1 inch at 100 yards is not actually 1 inch. It's about 1 inch. What it actually is pi over 3 inches, which is very close to 1. The 2 inches is actually 2 pi over 3 inches, and so on. Remember earlier when I discussed formulas with an input and output, and you expect the same units going in and coming out. Let's add the yards measurement to the 1 MOA column. That doesn't look clean or easy to use. I said at the beginning that for our goal in long-range shooting, minutes of angle accomplish that goal by coincidence, and mils accomplish that goal by design. Mils get us that easy calculation of the crust size. For 1 mil, all you have to do is take the range and divide it by 1,000. Minutes of angle get us a mess of math involving pi, but by coincidence, it happens to calculate to very close to 1 at 100 yards. Let's examine that more involved minutes of angle math involving pi, and the coincidence that makes the whole mess disappear. So what we have is the range to the target shown by r, which represents our radius in a circle. In order to use degrees when we know the radius, we have to first build out the whole circle using that radius, so multiply r times 2 times pi. Now that we have the whole circle, we can divide by 360 to find how much of that circle is covered by 1 degree, then divide again by 60 to find out how much of the circle is covered by 1 minute of angle. This is the mess involving pi when you use minutes of angle for precision shooting. Now here comes the coincidence. Remember earlier when I discussed how mathematical formulas are applied and that we're also doing the extra step of including the conversion from yards to inches in our calculation. Let's add the conversion from yards to inches into this 1 MOA formula. That means multiplying by 36. Now that 36 on top works nicely with the 360 on the bottom and reduces to just 10 on the bottom. Now let's also plug in 100 for our range. That 100 on the top with the 10 on the bottom reduces to just 10 on the top. And now the 10 on the top with the 60 on the bottom reduces to just 6 on the bottom. And now the 2 on the top with the 6 on the bottom reduces to just 3 on the bottom. And multiplying by 1 doesn't change anything, so we can eliminate all of the 1s. When we plug in the conversion from yards to inches and plug in the 100 for the range, the whole mess just disappeared and left us with pi over 3, which is close enough to 1 to basically just say 1. When we look at the actual math needed to use these units for our task, it's clear that mils is going to be easier to use. But the very fortunate coincidence allows for using minutes of angle as long as you want to measure the distance of the target in yards and understand your adjustment in inches. Outside of those limited circumstances, using minutes of angle for this task will get you a mess of math involving pi. This is the reason why people choose mils, because the actual calculation for mils are very quick and easy to do, and they can be done using any unit of measure, and they give you an exact answer. Unlike minutes of angle, which can only be quickly and easily used when you measure the distance to the target in yards and you want your adjustment in inches, and even that answer is not exact, it's just an approximation. Now, with all of that said, when choosing one or the other, the best advice that I've gotten is to consider the two following factors. First is which one are you going to be faster with? Because usually there's an element of time involved in shooting, and you need to get that calculation as quickly as possible. So whichever one you're going to be able to use more quickly to get an accurate answer is probably going to be a better choice. And the other thing to consider would be the people around you. Which unit are they using? Because if they're all using mils, you're going to want to be using mils too so that you can communicate with them and share your data. But if they're all using minutes of angle, then you're going to want to use minutes of angle so that you can do the same thing, share your data and communicate. So I hope this video has answered the question of why do people choose mils for you. Thanks for watching.